All right. ठीक है जी. So first let's understand what is your understanding of Newton's third law. Okay. Let's see the image you have. तो पहले एक डिस्कशन कर लेते हैं कि आपको क्या मालूम है न्यूटन्स थर्ड लॉ के बारे में. Okay. What do you think it is?
Reaction has an equal and opposite reaction.
Correct. So action has an equal
and opposite reaction.
Correct. I will just change it a bit. And they act on different bodies. Okay. Which means if you have two bodies, they need to have contact between them. That is the first condition. They have a contact, which means a man is standing on the ground. He needs to have a contact with the ground. So the force we are referring to, the equal and opposite reaction, needs two bodies to be in contact of each other. Once they are in contact of each other, if you apply a force, for example, you apply a force of 5 newtons here, okay, then this block number A will press against block number B, okay, and the way it works is there will be a mutual force between them. अब मैंने इन दोनों को अलग कर लिया. I have separated them out, and what I'm saying is you have A and B, and they have a mutual force. B is applying a force on A, and A is applying a force on B. So they act on different body, and these two forces are called as action reaction pair. They always exist as a pair and they act on different bodies, right? So these are not like internal external force like these. ये external force है जो न्यूटन सेकेंड लॉ में F is equal to m into A, इसमें कोई रिएक्शन नहीं आया आपको वापस, राइट? बट जो न्यूटन के थर्ड लॉ से जो फोर्सेस होती हैं वो हमेशा एक्शन रिएक्शन पेयर की फॉर्म में होती है, एंड दे एक्ट. सो इफ A is acting on B with F force, then B is acting on A with F force. So equal and opposite. It is not like this force, okay, which is an external force which will make A and B both move with each other. So although we are doing a slightly advanced level discussion, but let me also rake up this topic so that you get more clarity. So for example, you have a block and you apply 5 newtons on it. It has a mass m, and you can straight away write maybe the mass is 2 kgs, and I ask you to calculate acceleration. You say force is equal to mass into acceleration. 5 is equal to 2 into A, and acceleration is equal to 2.5 meter per second square, right? So this was easy, right? The external force of it. Now what I do is I connect this to another block. This is 2 kgs, this is 4 kgs, and this is now 5 newtons. First question, what is the acceleration of the system? So you will say these two blocks are a single block, so force is equal to, and they're touching each other, and there will be a contact force between them, which will be an action. But as far as the external force goes, my acceleration will be, this is A1 because I have two masses touching each other. So force is 5 Newton is equal to 6 kgs multiplied by A2 is equal to 5 by 6 meter per second square. So both the blocks have a force, an acceleration, which is this. So they are now moving with an acceleration. Earlier there was only one. Now if I were to ask you what is the force acting on this block, only this block, I know its acceleration, it's 2 kgs multiplied by 5 by 6. So it comes out to be 10 by 6, right? And what about the other one? The other block is mass is 4, and I multiplied by 5 by 6. So this is 20 by 6. 20 by 6 plus 10 by 6 is equal to 30 by 6 is equal to 5 newtons. So we know if each one of them is accelerating with 5 newtons, this 5 newton got distributed in two parts. One was a part which was 5 by 3 newtons. So this particular block got 5 by 3 out of 5 newtons. The balance, which is the 20 by 6 part, right, which is 2, this was 10 by 6, so this is 20 by 6, so 10 by 3 newtons. The 10 by 3 newton, the balance of 5 newtons, 5 by 3 went to this, and the 4 kg got this force because it was double the mass. So 5 newton got bifurcated as 5 by 3 and 10 by 3. This is the way it got distributed. So just an introduction to start solving bit advanced level questions, but this is not the point we're discussing right now. I have done this deliberately so that I can actually explain you the meaning of the action and reaction pair, which you will come across in many situations. Okay, so this is your situation number 1, which we are considering. The blocks are touching each other. This is your 5 newton, this is 4 kg, and this is 2 kg. And you have found out, this was 2 kg, sorry, this is 4 kg, and you have found out what is the acceleration. Same, because they're touching each other, it becomes a single mass of 6 kg. You found out. Now the question is, here there is an action and reaction pair existing. The question is, we have to find that action and reaction force which is between the two contact surfaces. So you have two surfaces, surface number 1, surface number 2, and therefore there is an internal force which the block number 4 kg is giving to 2 kg, and an equivalent force which 2 kg is giving to this one. Okay, it is coming from the 2 kg. So this is F and F. Okay, so we have to find F actually. If I just look into 2 kg, okay, if I just consider 2 kg now, and I look at 2 kg, I say, okay, 2 kg is getting a 5 newton force from here. Agreed. And it is also getting a reaction pair from the other block, which is the 4 kg block. Okay, now what happens? The net force on this, because it is moving rightward, we've already found the acceleration of this. We know external forces are now looking like these. So 5 minus F is equal to 2 into A, right? We found the A from the above concept कि दोनों एक ही block है, तो 5 by 3 A. इस rule से we were able to find the acceleration, treating them as a common block. So I'm just putting it here as 5 by 6. So if I do this, I get 5 minus 10 by 6 is equal to F. Okay, so 5 minus 5 by 3 is equal to F, and therefore 15 minus 5 by 3 is equal to F. So F is equal to 10 by 3. So we were able to find a reaction force also. And if you notice, the 10 by 3 force you've got is same as the force which is acting on the 4 kg when we use the concept of second law. So second law में जो हमने 5 by 6 निकाली थी acceleration, उसको 4 kg से मल्टीप्लाई करा था, तो 5 न्यूटन में से 10 by 3 न्यूटन इसको मिल गया था. और अब भी जब मैंने वो कॉन्सेप्ट यूज ना करके एक्शन एंड रिएक्शन पेयर करा, तो मेरा रिएक्शन पेयर जो आ रहा है 10 by 3 आ रहा है, मतलब 4 kg के ऊपर 10 by 3 न्यूटन फोर्स जा रही है, और 4 न्यूटन भी 2 kg के ऊपर 10 by 3 जा रहा है. इसका मतलब, सो ऑब्वियसली you have understood, I hope you have understood कि there is a hidden reaction and action force between these two blocks, although the system is being exposed to 5 newton, but overall there is a force appearing between the contact surfaces of the two blocks. Any question so far in your mind? So your first sentence, action has an equal and opposite reaction, but I just changed it, but they act on different bodies. Action is acting on one and the reaction is acting on the other. 2 kg has started the process. All right, let me introduce you to one more concept here, which is, if you, for example, now that you know that if you have, so this topic is, obviously you're learning about action and reaction pair. Yes, you are. you are learning about it. But parallelly, you are also understanding the meaning of the contact force. That a contact force gets distributed between the masses in inverse proportion. Right? So if this particular block is considered, it got major part of the force. Sorry, not inverse proportion, direct proportion. Right? So this is 2 kg only. It got only some amount. And if you referred 5 by 3, but 4 kg got 10 by 3. So this 5 Newton force finally gets split between the blocks. And one more point. If you notice if the F we have found out, we will call this F as not only a action and reaction force, but also it is a contact force. Why? Because it appears only when there are contacts. This force has nothing to do with contact as in two surfaces touching each other. No. But so let's take another example. And how does the force then spread its wing across the blocks? So I have 3 blocks now. All right. And I apply a force of 20 Newton here. This is 5, 10 kg and 5 kg, right? 5 kilogram, 5 kilogram, 5 kilogram. Now this is 20 Newton. If you look at the overall system, M system, the force is looking at the system and saying, I am being asked to push a 20 kg system. So the overall system mass is 20 kg. The overall external force on the system is 20 Newton, and therefore the acceleration is 20 upon 20 is equal to 1 meter per second square. Fair enough. And now the question is, where are the action and reaction forces coming into picture? So let's see that view now and understand it. So this is one place where the contact is happening. This is another place where the contact is happening, right? So therefore you will have 2 pairs acting. So I'm drawing 5 and 10 here. The first one, A, B, C, and this is action and reaction pair, right? So this is the next layer is again 10. So 10, by the way, has one force coming from this 5 kg, but also has a force coming as a reaction from here. So if you notice 10, which is between the two 5 kgs forces, it has a mutual force coming from the left, and it also has a mutual force coming from the right block. And this is a action. The reaction was F2. This is the action. So the reaction is. So if you notice now, what you're able to see is something called as a free body diagram also. So you can see if the bodies are no longer in touch with each other, but are separated out, they're free. They're not in contact of anyone. And the notion of free body diagram. So I will look A as an isolated system. I will say A is having a force which is F1 coming as a part of the mutual forces between 5 and 10, and it also has a 20 Newton force on it. So if I want to calculate F1, I know the mass 5 kgs. I will write Newton's second law, 20 minus F1, because these are vectors, is equal to 5 into A, which is 1 overall system. So F1 comes out to be 15 Newtons. Let's look into F2. Okay, let's look into the last mass, 5 kgs. What is F2 going to be? This is the only external force to which 5 kg is being exposed to. So 5 multiplied by 1 is equal to 5 Newtons. Which means the net force on 10 is a difference of these two. F1 minus F2, because if you look into the middle, it is getting F1 from here and F2 from here, right? So if you subtract, F1 is 15 and 5, right? So 10 Newtons. Now look at this, that you applied a force of 10 Newtons and it passed through the contact forces, appeared as 15 Newton force or mutual force between these two, and a 5 Newton mutual force here. If you apply a force here on a system of masses, which is 5, 10 and 15, which is some 20 Newtons, that force is also getting transmitted through the blocks. It is getting transmitted. First, it makes an appearance here of 15 Newtons, lost, balance 5 Newton is appearing here. So this whole 20 Newtons will keep on transmitting. If you increase the number of blocks, it will reduce obviously the action and reaction force. So this is 1, 2 block, third block, fourth block, you apply a force of 50 Newtons. This is 10, 5, 10, 5. First pair will come here, the second pair will come here, and the third pair will come here. And if you add those forces in one direction, because there is a direction which is among the pair which is leftward, and then there is a direction which is rightward. If you add them, you will find them to be 50 Newtons. So the action and reaction pair that appears at the point is called as a contact force also, and is nothing but the transmission of 50 Newtons passing through each contact, right? And you can obviously treat this as 10 and 10, 20, 30 kgs, and therefore the acceleration is 50 upon 30. And then you can write individually, make free body diagrams first. So this is 50. The first pair, F1. What is the acceleration? We have already know that. So it is moving, the whole system is moving towards right. So 50 minus F1 is equal to the first mass into A. You know the value of A because you just found out. You can find the first contact force which is appearing here. And then you can do the same for this and this, etc., etc. And last one obviously is getting some component of 50 Newton traveling through these blocks, reaching here and getting applied here as a reaction pair, and it will give back 10 Newtons this. So this is the last force, maybe F3. So F3 is equal to M4 into A. If you know the mass, you know the acceleration, you can straight away find that force which makes an appearance here and is responsible for 5 Newton in isolation, moving with an acceleration of 5 by 3, which is same as the acceleration of the system. So you learn two things. One, there is something called as action and reaction force acting on different, and in the case of blocks, which is a very important situation to learn, this was a situation where the force is getting transmitted through the help of action and reaction pair here. Transmission point, transmission point, transmission point. The sum of all these forces has to be 50 Newtons. So when you apply 50 Newtons, a part will be taken away here, a part will appear here, and a part will appear here. The sum is going to be 50 Newtons. Any doubts in your mind so far? कुछ problem नहीं समझ में आया, क्या हुआ? What happened? कोई doubt? Any doubt that comes to your mind?
सर ये जैसे ये फोर्सेस डिस्ट्रीब्यूट हो रही है, एक बार आप दोबारा बता सकते हो क्या?
हाँ. So if you have two blocks, you apply a force X Newton here. This is M1 and M2. Wherever they are touching each other, there will be a generation of a action and reaction force. Because they're touching, you're pushing, right? So M1 will push on M2. If it pushes on M2, this is that force on M2. And then M2 will also push it back. Is this clear?
Yes.
This is your action and reaction. This is action, this is reaction. This part is clear? All
Yes.
right. Fair enough. Now, if you notice, let's draw the free body diagram of M1. What are the two forces on? So this is X Newton coming, which is an external force, and M2 is applying F on it. Understood? I'm drawing the free body diagram of M1. It's a free body diagram, means isolated from other masses. Look at it as an individual masses and what forces are acting on it. So now the net force, which is a resultant on this, will be X minus F is equal to M1 into A. This is the net resultant force acting on M1. This is part of the action-reaction pair coming from M2. This is the external force. So this is the second law of equation for M1. Any doubts so far in your mind? Why did we do this? This is a free body diagram of M1.
No, sir.
All right. Now let's talk about M2. What is the only force acting on M2?
F.
F. Okay, let's say F. So how do we write the second law of equation on this? External force is F is equal to M2A. Agreed? That is the only force acting on M2.
Yes, 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 sir.
The action and reaction force. Okay, right? So X minus F is equal to M1A and F is equal to M2A. Let me add first. I will get X is equal to the X, which is the external force, is equal to M1 plus M2, which is like a common system of two masses, and therefore the acceleration is X upon M1 plus M2. Right, so this is your acceleration in meter per second square, which is external force divided by the total mass. ये तो आना ही था. Nothing great, right? This had to come. कोई बड़ी बात नहीं है. But the point is we are supposed to find F. Okay, so let's say what is F now. All right, so let's say we know the acceleration. So F therefore is equal to m2 multiplied by x upon m1 plus m2. I have just used this equation for mass 2. In the mass 2, F is equal to m2a. A I have found out. I'm just substituting the values. Look at this value, m2. ठीक है? This is the net force on M2. Any doubts?
No, no, sir.
Okay. Let's go to mass 1. I will redraw the free body diagram. This mass had a force X, right? And then it had a reaction coming from the other mass, which was F. If I were to calculate this now, which is what is the net force on this, can I do X minus F?
Yeah.
Okay, so let's do that. So X minus M2X upon M1 plus M2.
Okay.
M1X plus M2X minus M2X upon M1 plus M2 gets cancelled, and you get M1X upon M1 plus M2. So if I were to go ahead.
इससे हमने अचीव क्या किया?
All right. So what have we found out now? For external force on mass 1. Net.
Okay.
And what was the force which we found here? The net external force on M2, right?
ये नेट फोर्स का एक्सप्रेशन आ गया.
Individual masses के ऊपर.
Okay.
All right. Let's do one thing now. Now we know F. Now we know there are two blocks. I'm drawing them separately. So we applied an external force of X Newton, out of which how much did this get? Right? We just calculated.
हाँ.
And we also calculated how much did the other block obtained, which was this. M times this, right? This one. So I'm writing this also. हाँ ठीक है. Very much expected था. M2 X upon
1 plus M2.
Right. And is this not same as the action and reaction force also? It is, right? That is the only force acting on M2, the action and reaction. Agreed? All right. So let's see what happens. If you apply a force of say 20 newtons, the mass of first is 15 kgs and the mass of the second one is 5 kgs, right? So let's calculate the actual values of this. So this will be 15 multiplied by 20 divided by 20 is equal to 15 Newton. So you started with 20 Newton applied on contacted masses, and now out of that 20 Newton has been consumed by this. Sorry, 15 Newtons has been consumed by the first mass. Where will the where will the balance 5 Newton go?
M2 वाले में.
M2. So which means the 20 first part of it gets transmitted to the first mass as 15, and then the balance jumps to the next mass. So this 20 Newton is jumping across masses. And using what? What was that? What was this? Action reaction pair?
Yes.
That's a point we're trying to make. That action and reaction pair is helping with the transmission of the 20 Newton force in each of the places where there is a contact. That action and reaction pair also gives you information about not only the Newton's law working on different bodies and there is an action reaction, but this is an application also. That action and reaction actually is appearing in the value which is nothing but the sum of all the forces will result in the net external force. So which means if you have first mass, then you have the second mass, you have a third mass and a fourth mass and a fifth mass, right? For example, this is x kg, this anything, right? X, Y, Z, A, B, and you have an external force acting on it. If you have to find the net acceleration, straightforward, right? F upon x plus y plus z plus a plus b meter per second square. This is the acceleration of the whole system. Second question is, how is this force getting transmitted through the masses at the contact surfaces? Who does that transmission? Which force appears here which is helping with that transmission? The action and reaction force.
ये सारी connected bodies हैं.
Yes. Connected नहीं, contact. कनेक्ट तो थ्रेड से भी हो सकती हैं ये. अंडरस्टूड. सो एक्शन एंड रिएक्शन पेयर होता है, ये तो दिख गया न्यूटन्स थर्ड लॉ में. देयर इज एन एक्शन एंड रिएक्शन. यू ऑल्सो सॉ इट वर्किंग. हाउ डज इट वर्क व्हेन द मासेस आर इन कॉन्टैक्ट विद ईच अदर? हाउ डू दे अपीयर? एक लेफ्ट पे जाता है और दूसरा दूसरे पे लग रहा होता है, लेकिन उनके बीच में होता है वो. और एंड इट्स मोर इंटरनल इन नेचर. The action and reaction is an internal type of force. This is more external, right? It is appearing as a pair. You cannot have an action and reaction pair without a pair. But where is a pair for this? There is no pair, right? But action and reaction is always having a pair. Understood?
Yes.
All right. Let's look into one more situation, which is the most common situation you can think of. So there is a ground. This is the ground, right? Now you have a block. So what we studied earlier was horizontal contact, which is, this situation, which is horizontal in nature. But you can also have vertical contact, right? So this mass is now pressing the earth with a weight of its own, which is mg. The earth is applying force on it, which is n. So this mass is in equilibrium because the force it is experiencing from the earth is mg. It is pressing earth with this force. So this is a force being supplied by this mass to Earth. So Earth is getting applied with the force of mg, and Earth gives it back the normal reaction. The weight which you see on the weighing scale is not actually mg, but the normal reaction which you experience. This is also pair. You press the earth presses you back. So when you say mg, actually it's wrong. It's not a weight. The weight is a normal reaction in vertical. But more importantly, if you press something, it presses you back with the same normal reaction. And this is called normal reaction. So magnitude wise, both are same, yes, but direction wise, both are not same. Mg is the force which the block is giving to the earth, and then the earth gives it back what is called as a normal reaction. It's perpendicular to the surface. So if you say perpendicular, what does it mean? If you have a situation like this, and this block, instead of being on a horizontal ground, this is mg, a component of it pulls it down, this is theta, and then there is a component of the weight which is pressing the block. If you press the block like this with mg cos theta, then the inclined plane presses you back with the normal reaction. So your normal reaction is mg cos theta. Mg cos theta is the force with which the little block presses the inclined plane. The inclined plane in turn presses back the block with the n, and the magnitude is same but the direction is different. Let's take one more example where you can experience normal reaction. This is your wall. This is your weight. If you leave it like this, it will fall down to ground because it is getting pulled by a weight, and it is not in touch, so it is not getting any normal reaction in turn. What is that you do? And here comes the contribution of the normal force also again, like an action and reaction. You press this block with a force of 50 newtons. That is the only force which is there and reaches here. Okay, so 50 Newton is the force being experienced by the wall now. The wall in turn pushes it back with a force of 50 Newtons. Okay, so if it pushes it back, so what, right? Now, friction is calculated with the formula of mu multiplied by n. How much friction will be there between the block and the wall is dependent on two quantities, the frictional force and the normal reaction. Don't worry about mu. This is nothing but we will study coefficient of friction. Right now we just worried this block is static. Okay, it does not move. By pressing it like this, you generate a normal reaction like this, and then you see that the block is not falling, because when there is a normal reaction coming towards the left, there is a frictional force getting generated perpendicular to the normal reaction, which is given by mu n, and this mu n balances the weight. So mu n is equal to mg. Normal reaction, if you press something down, for example, you are walking on the road, right? You're walking on the road. When you walk, you are pressing back down the earth. The earth is pressing you up, and there is a frictional force between you and the ground here. The frictional force is perpendicular to the direction of normal reaction, and therefore if you notice this also, you don't have to worry about friction right now and all that, but I'm just showing you applications of normal reaction, how important it is. If this is the normal reaction, the body wants to go down. If there is a coefficient of friction that exists here of some value less than 1, frictional force. It is mu multiplied by n. And this may or may not be able to hold this. If mu n is greater than mg sine theta, the block will start going up. However, if mg sine theta is greater than mu n, the block will start. If they're balanced, then they're balanced. External forces are balanced. The block will not move. Okay. So the point being made is wherever you have two surfaces coming in contact with each other, you will end up having a position or a new force, which is the action reaction force called as normal reaction. Any doubts in your mind pertaining to normal reaction? I also told you a straightforward combination of Newton's second law and Newton's third law together in a question. We were applying external forces, calculating net acceleration, then looking at individual masses, applying Newton's second law to calculate individually using a free body diagram. And also we have seen some glimpse of the action and reaction pair acting when you are measuring your own weight. When you are measuring your own weight, one and the same thing. The earth is pressing you back. In an inclined plane, the inclined plane presses you back.
सर नेट फोर्स 0 लगेगी इसमें.
किसमें?
इस वाले केस.
इस वाले मतलब?
नॉर्मल रिएक्शन और.
Which case are you referring to?
This one, sir.
हाँ.
ये
When
वाला.
you say हाँ.
तो like net force का 0 है कि normal
Of course it is not moving, right? So it is getting balanced. Huh? Look at the concept. This is 50 newtons. You are applying a 50 newton from here. The wall is giving it back a normal reaction of 50. So what happens to this? 50 on both the sides, right? This is horizontally the move नहीं कर पाएगा ना?
Yes, sir.
This is a reaction coming from the wall. This is the external force it is experiencing. It is not the source of force. It is experiencing. Now, this wants to go down, but a friction will come. So this is if you keep a book, you press it gently, it will still fall. You start pressing it hard, horizontally. It will not go down because of static friction will come in to balance its weight. And sometimes you will see, if you press it too hard and there is a particular way of keeping them in contact, you will start seeing the book will start going up. Because mu n will beat mg. There are ways to do that also. But for the time being, let's only keep it very simple, which is this. Any doubts in your mind pertaining to the concept of...
No, sir.
All right. Okay, so very important concept of all right. And then there is another very important situation, which is the situation of how if you are in a elevator, which is a lift, right? And then you have to measure your weight. What happens if you want to measure your weight in the lift? That is a question, right? This is a very important question, which initially you learn from... and then you start applying it in different situations. So let's see what happens to a block of mass kept in, or a man's weight being measured using a weighing scale. So there is a lift. This is the weighing scale. Okay. The man is standing on the weighing scale. Okay. Not a great diagram, but whatever it is. So this is a man. Scale. Okay. Now the lift is stationary. It is not accelerating. So acceleration is 0. Can be moving with constant velocity. May. The weight of the man is downward, and he is experiencing a normal reaction, right? And we know, since he's not flying up or down, the normal reaction magnitude is same as mg. The force with which he's pressing down on the lift surface is mg. The lift is giving back n, and therefore the weighing scale shows you the correct weight of the man, the real weight. constant velocity, can be constant velocity or can be stationary, but there is no acceleration. Now, when the lift starts accelerating, and we have this weighing scale and the same man standing on the lift. All right, this is a man standing on the lift. We have to, this is going upward, accelerating upward. Now the man is still pressing it with mg. He has no choice and gets back the n as a normal reaction. But if you notice, the net weight which you will see on the weighing scale is the sum of the upward forces the man is experiencing, which is n plus ma. N, you know, is mg plus ma, because there is an external force also upwards, and the normal reaction is also an upward force, constitutes the weight. But for the measuring scale, the weight will be the apparent weight, which is mg plus a, because the net force, which is called as a weight, as in weight, is not the mg which is being pressed by the man on the weighing scale. No, that is a force which is experienced by the lift. The man's weight is the all the upward forces acting on the man. The n plus ma will give you the apparent weight when the man is accelerating upwards. And similarly, if the acceleration is downward, okay, so keep the weighing scale, same man, okay, now go down. Okay,
सर
हाँ जी,
सर ये m क्या मास ऑफ द मैन है?
yes, very much. We are talking about apparent weight of the man. So this is the real weight and this is the apparent weight. Apparent, it appears to the world, but it is not the true weight. If the acceleration is downward, he is still mg and this is n, and he is standing there. So if we notice, the normal reaction, right, is getting cancelled by a certain force. So it will be mg minus ma. So you will see slightly less amount of reading because your normal reaction is reduced by an amount this. Normally you would have measured this as your weight. You call the normal reaction as a weight, but it is getting cancelled by a. So it gets cancelled. The magnitude was this much, but got cancelled. If you're going down with an acceleration, you will feel lighter. If you go up very fast accelerating, you will feel heavier. This is your reduced apparent weight. When you're going down, you will see a different reading. When you go up, you will see a different reading, which is an addition. And if you're moving with constant velocity or acceleration 0, you will get n is equal to mg.
Okay.
Okay. Very important topic, because you will see many questions now where students miss the point. I will send you a video, have a look at it. Students will miss this point because nobody gets this point that if you're standing somewhere, for example, a man is standing here, okay, on a rooftop or some 10 feet high or whatever, right? And he is standing here, right? There is a mechanism which has been built where there is a pulley here and this man is pulling with some tension, and this pulley is fixed somewhere on the wall. Maybe there is a wall here and this is fixed and there is a weight here, all right? And the man is applying force to bring this mass up using this pulley system. Obviously, pulley is being used to turn the direction of the force, right? It can change the direction of the force. So the weight transmits through the tension. You don't need to worry about what I'm talking about, but pulley at least is capable of changing the direction of the force. I apply the force here and I get a result here, right? So if I apply downward, I get an upward resultant. The weight starts going up. That's the beauty of a pulley. It's a machine after all, but we are not worried about that. If you notice this man, He is pulling the, okay, this is the man, okay. If you notice him standing on the ground, he is pulling the string downward because he wants to pull this upward. When he pulls down the string downward, right, the string also is applying a force on him also. He's also experiencing the force, right? Which is for the purpose of man, if you notice the man is this. And he's also experiencing a normal reaction from below. So if this force which he's experiencing upward becomes too large, he may get lifted up, which is what happens in a weight training scenario. If the tension in the string, which is the force being experienced by the man when he pulls down the string, becomes larger than man's weight, then that weight will take up the man and the normal reaction will not exist. If you leave the surface, there will be no normal reaction on you then. But just look at this diagram. A lot of people will say, okay, this man is getting pulled up by the tension, but will forget there is a normal reaction also acting on the man, which is helping the man move upward apart from this tension, which is why he feels a pull upward. Otherwise, he's balanced. If there is no string, he feels balanced. There is a ground. He is applying mg. The ground is giving him normal reaction, but not anymore. He has a string to which he's connected, which is trying to pull this man. So whenever you do your free body diagrams, and we will practice those free body diagrams using some questions, quizzes, and then you can try, whether you've learned how to draw a free body diagram. But what you're learning right now is the Newton's laws of forces, especially the third law, combined with the second law, and then various situations of action and reaction pair in situations. Most of the people forget to apply the Newton's third law. That's a point I'm trying to make. They will not apply this because they tend to forget it. Any questions that come to your mind?
No, sir.
Okay, so let's do one thing. Let's try and solve the one question, and let's see if we can understand it. Okay, no friction, nothing, straightforward knowledge of, you don't need to know work done, you don't need to calculate this. We'll start with a simple question so that you can apply. Okay, let's see if we can do a simple question. Okay, okay, I will just paste this question and we can do this. Okay, ये मैं थोड़ा easy लेना पड़ेगा start में, and then we can make it slightly.
सर का लाइव स्ट्रीम रोक सकते हो क्या?
वो क्या होती है?
आप लाइव स्ट्रीम कर रहे हो?
हाँ, कुछ जा रहा है उसमें?
सर आ रहा है,
क्या आ रहा है?
यूट्यूब पे हो रही है लाइव.
ठीक है ना, इसको हम तो दिख ही नहीं रहे इसमें.
दिख रहे हो सर?
Both?
सर आप दिख रहे हो खाली.
You would not be visible.
मैंने इसका चक्कर में बंद कर दिया था काम.
Okay, I'm just looking for an entrance question. JEE में आया हो कोई, which you can try and solve.
पूरा आपका दिख रहा है यूट्यूब पे.
क्या दिख रहा है?
लाइव स्ट्रीम पूरी
नहीं उस वो तो दिखेगा ही ना यार, मैं अब क्योंकि रिकॉर्ड करके डालता जा रहा हूँ उसको जब मौका
सर।
मिल रहा है. ओनली द स्टूडेंट इज गुड, इंटेलिजेंट स्टूडेंट.
क्या बात हुई सर?
All right, let's do this question. I think this is very interesting. Okay, it's a question which pertains to you to apply yourself a bit and see if you can understand this concept wise. Okay, you will do this question. Let's do this. All right, you have to solve this question now.
Mutually perpendicular.
X and Y. Trying. Okay. So external forces are acting. The only thing is, you know vectors now. So you know law of parallelogram. You also know how to do resolution. You know Pythagoras theorem. Okay, F3 are mutually okay. If you apply these forces, F2 and F3 are mutually perpendicular. Okay.
F1.
Okay.
F1 को कहाँ लिखा?
You can show it anywhere. So इसका मतलब दो का रिजल्टेंट जो है वो
Direction. Like ऐसे. F1.
You know vectors now, right? You have a sense of vectors. You use your knowledge of vectors to say how will 3D. Okay, so you have applied in 3D. They will never cancel. I, J, K. They will never cancel each other. Are acting on a F1 and F2 are okay. You have drawn them perpendicular. Then, so why have you drawn 3D is not clear to me, because this was a simple situation where if you have a mass like this, which is acting upon by two forces which are mutually perpendicular, the resultant is this, right?
Yes.
And if I apply a force here, it will cancel it. So F1 and F2, the resultant is this.
F2 है sir.
Jovi, whatever names you can give them. F2 and F3 are mutually perpendicular, which means if you get a resultant of both of them, which is under root of F2 square plus F3 square, then what is this? F1 is equal to what? is one way to look at it. Now, what are you doing? You're removing the force F1. You have to calculate the acceleration of the particle. So which means you will remove this.
So खाली मेरे पास यही बचा है.
Come again?
ये
हाँ.
नहीं.
Yes. F2 and F3 are mutually perpendicular. If the force F1 is now removed. So this was a situation where F1 is equal to, yeah, we have written that. Now F1 is taken off, which means we will allow this body to travel with the resultant force. Correct.
So options में like अच्छी है.
What is the answer? Answer क्या आ रहा है?
ये आ रहा है.
Okay, let's see. So the two forces are acting at right angle to each other. Yes. They are acting on a particle and are mutually, F2 and F3 are mutually perpendicular. So this is the resultant. F1 therefore has to be opposing. Yes. And then you remove F1. Then the acceleration. Yeah, I think none of the choices is correct then. I don't think so, that because they are not in the same line, you cannot subtract them. They cannot also be multiplied by any chance. Particle, if the force, this is the only way. So I think our answer is correct, don't worry. Nothing to worry. All right. Okay, next question. Let's see if we can solve it. Okay. I'll just paste the diagram. तो वेक्टर की नॉलेज और लॉस की नॉलेज, अभी बहुत सिंपल क्वेश्चन करें. वी नॉट डूइंग कॉम्प्लिकेटेड क्वेश्चंस, वेरी सिंपल क्वेश्चंस दैट जस्ट हेल्प यू विद अंडरस्टैंडिंग द बेसिक. दैट्स ऑल. वी आर नॉट डूइंग एनी complex, complicated type of question to start with. Contact force, I'm sure, was new to you. वो नया होगा थोड़ा सा. But gradually you will realize that that too is.
सर आपकी स्ट्रीम में से कोई नहीं देख रहा है.
कोई बात नहीं. Makes no difference to me. हम दूसरों को दिखाने के लिए कर ही नहीं रहे. अपने आप धीरे धीरे धीरे. One block pushes the other. We've already done this. हमने एलिवेटर का एग्जाम्पल भी कर लिया वेइंग स्केल का. ओके. Okay, one more numerical and then we will do the connected bodies which you mentioned. Okay. Okay, here is a question. Good question, okay? And you will see why, because it involves your knowledge of vector. Okay. next question.
भाई मेरे का साइज छोटा कर दो
Okay.
ज़्यादा बड़ा
Raghav Shrivastava. I am in class 10th. If you go back to the previous question, I think if you look into the previous question also, look at the choices. A, right? हमारा जो F1 था वो ये F1 ही तो था ये A चॉइस में. This one. ये F1 ही तो हमने हटाया था और F1 कितना था? The magnitude of F1 was this, right? So we could write F2 square plus F3 square by F1.
sorry क्या हम एक्सेलरेशन का मैग्नीट्यूड ही ले ले क्या
Force is a
नहीं
vector.
एक्सेलरेशन का ही मैग्नीट्यूड अगर ले लेंगे तो फिर हम शायद से फोर्स निकाल पाएंगे
You mean to find the magnitude or direction. Force is a vector. So acceleration or force एक ही direction में होगी, right?
हाँ जी
F is equal to m into a.
यस मैग्नीट्यूड ऑफ ए
हाँ. A part or B part? Which one are you referring to? A या B? B you're referring to B part. Magnitude of resultant force.
यस सर
ठीक है. What about A?
वो कैसे निकालें
Force is equal to mass into acceleration. It's a vector. So 3 multiplied by 2i plus 5j is equal to 6i plus 15j is the answer. The magnitude of this vector is 6 square plus 15 square.
सर वैसे एक मैग्नीट्यूड निकालने के लिए एक्सेलरेशन का मैग्नीट्यूड ले लेते हैं
What for? Why do you want to waste time? One and the
उससे
same thing. One and the same thing. For why not first find the vector, force vector, and then take a magnitude?
ठीक
Unless you know how to do this. अगर आपको resultant force as a vector नहीं निकालने आता, then you're focusing on only 2, right? Which is the easier part. ये vector की तरह कैसे लिखना है? देखो ऐसे लिखना है. So these many newtons.
ओके
Straightforward, right? Point is force and pressure are one and the same thing, direction wise. There is no major difference between them. Okay. अभी नहीं कर पाओगे ये वाला. Alright, simple one again, but we'll give you a glimpse of. 16th. So knowledge of vector, knowledge of force coming all together. Correct. Yes. ठीक है, आता है, छोड़ दो. Understood. You get it. Understood. So let's move with the next topic, okay? And the next topic is the topic of how do you solve for connected system, right? Like you said, connected. Which is more to do with tension in a string. Very important topic. If you have a block of mass, first consider horizontal, and you apply tension, so-called tension. Actually, tension is what? Your hand is pulling. This is your hand. The force is coming from your hand. The force gets transmitted through a medium called a string and gets applied here. Actually, your hand is here, but through the string, a force travels, which is called as tension. So if you apply 5 newtons force, the 5 newton travels and gets applied on this mass. So force is equal to 1 into 5 is equal to A is equal to 5 meter per second square. So whatever is your stuff to the string, if I connect it vertically, and this is 1K, then 1K to 9.8 is equal to 9.8 downwards. But the string with which this 9.8 Newton has will pull it up with 9.8. The string is pulling the string. The weight, sorry, is pulling the string. So the force gets transmitted till here, and on the other side it reverses. So now the wall is getting pulled by 9.8 newtons. So first thing, at this point of contact where the string and the mass meet, this is a contact point of the string and the mass. If the weight is 9.8 kgs, the same weight is here, and this weight is getting transmitted and making an appearance here as an action and reaction. Obviously they're not on the same place, they're not in contact, but they are at some distance from each other, acting on different bodies. So the reaction of weight, which is this, travels through the string and tries to pull down the, and therefore if you have this weight hanging with 9.8 newton as your force, okay, 9.8 newton weight, sorry, okay, what you call is weight, and you are having a string and this is your hand, your hand will experience 9.8 newton force. This is the string. Through the string, this 9.8 newton goes up, and on the other side it behaves like this. On the side of the block it behaves like this. Sorry, we will draw it a reverse diagram, which is this, okay, which means we are pulling the wall down. This is the way. So if I draw again this diagram horizontal, this is my hand. The force with which I apply on the string travels to the block and appears like this, and on the hand it appears like this. So the tension we are worried about is always at the contact point, wherever the string is getting connected to something else. Contact point. This is where you're worried about always. Let's take a simpler example. Instead of hand and hand, let's take a horizontal block, which is more famous and easy to understand. This is the situation. I connect it through a string and I apply a 5 newton force here. This force will appear here and will be pulling this mass with 5 newtons. At this point, whatever tension appears, right, at the edges again, it will again be directed away from the mass. This is away from the mass, this is away from the mass, and this too is away from the mass. Away from the mass, okay? The mass is getting pulled. This so-called reaction is pulling this mass in this direction, and its counterpart on the other side is pulling this mass on the left side. So the direction reverses on the two sides of a tension. In the middle, everywhere the tension is balanced because it is appearing as exactly these two pairs. So it appear as a pair here, get cancelled. So throughout the string it gets cancelled and only makes an appearance and impact at the edges. Any doubts in your mind? Where does it act? How does it act? Connected bodies through string. Tension in a string. Any doubts?
एक बार एजेस मतलब क्या लगता है इसे?
Voice is not clear.
सर एजेस पे क्या लगता है?
Tension. वही पढ़ रहे थे हम अभी. Topic is tension in the string. Answer is it appears at the edge where there is a meeting point between the mass and the string. So if you have multiple masses getting connected, then this string at the extreme two ends or the edges will exhibit the behavior of tension. This mass will get pulled away, and this mass will also get pulled away. Tension pulls away. It never pushes, it pulls. If this is your mass and it has strings on both the sides, because you're pulling from here with your hand, so the tension travels here, it makes an appearing, pulls the mass. On the other side also it pulls the mass. This mass is getting pulled. On the other side also it is getting pulled. Always away from the mass. The pulling is away from the mass. Away from the mass. Away from the mass. So the string is only a medium. String is only acting as a medium for transmission of the force you had in your hand. One string, one tension. Separate string, separate tension. So if I have a situation like this, single string, single tension. If this is the end, the tension is pulling the mass upward in both the cases. And if you look into this pulley, at this end also, the tension is pulling it downward. This pulley is also experiencing a force from both the sides, away from the pulley, away from the block. Single string, single tension, never changes. Let's see a simple situation, okay, which is the horizontal masses, so that in theory this is how it looks. How does it look in reality? Okay, so this is your two-string system, and I'm applying a string, a force of 5 newtons. This is 2 kgs. This is 3 kgs. Question is, what is the tension in this string? Okay, which is making an appearance here. If I make a free body diagram of 2 kg, one tension is coming from hand. The string number 1 is getting pulled. So pulled. On the other side also it is pulled, but these are two separate tensions because they are two separate strings. Okay, we know 5. This is 5 newtons. So whatever force you applied got transmitted through the string, made an appearance at the end, and pulls the block. So 5 minus T2, if this is T2, in the free body diagram, is equal to 2 into A. Let's look into this. We don't have to worry about the free body diagram of the string. We worried about only the free body diagram of the masses. This is your tension, which is a free body diagram of the second mass. The tension is pulling it away. The same tension which made appearance here is now making an appearance here. This is so T2 is the only external force on 3 kg, 3 into A. So my second equation is T2 is equal to 3 into A. Let us solve this and add it. So 5 is equal to 5A, A is equal to 1 meter per second square, T2 is equal to 3 Newton. And therefore this particular body, this T2, will generate an acceleration for this. And what is the net force acting on 2 kgs? T2 is pulling it away with 3 newtons. This is 5 newton. The net force is 2 newtons. same, the 5 Newton force is getting distributed through the strings now. 2 newtons were obtained by this and 3 newtons were obtained by this. Again, distribution of force. Let's look into another situation. So this is your pulley. Okay, this is a pulley and this is your 5 kg. This is 15 kg. Question is, what is the tension in the string, single string, and what is the acceleration of the system? All right, so let's look into the free body diagram of 5 kg. This is the tension. It will pull the mass upward at this. It always pulls up. This is the weight of the block. The earth is pulling it down. The net, because this is heavier, obviously, the system will go like this and downwards on this. Okay, so we have drawn one free body diagram and let's write the equation. Tension will win minus 5 into 9.8 is equal to the net force on the 5 kg block. This is the Newton's second law getting applied on the case of connected bodies. Look into the other one. The weight is bigger. The tension is pulling it. It always acts at the edges and is pulling it up. Minus tension is equal to 15 into A. Let's add these. M2, 15 into 9.8 minus 5 into 9.8 is equal to 20A. A is equal to 9.8 divided by 2 is equal to 4.9 meter per second. This is the acceleration of the system. Obviously upward है तो ये plus हो जाएगी, इसको minus लिख सकते हैं आप, doesn't matter. But we are worried about magnitude right now. If you put back the value of A here, you can find the tension also. So tension is going to be 5 into A plus 5 into 9.8 is equal to 5 into whatever you're getting here, 4.9, and another 5 into 9.8. So this will become around 49 and this will become another 24.5 or 25 point, jo bhi aayega approximately. You can add these two. So that is your tension in the string. What is the force acting on the pulley? The pulley is getting connected here twice. The string has only one job at the edge. Pull everything in the opposite direction. If it is pulling it like this, then the pulley gets pulled downward. But the pulley is massless. Since the pulley is massless, therefore the net force on the pulley is 0. But if this is another string here, this is another string, this will also have a tension, which will be, if you draw the free body diagram of this is a string. The pulley is experiencing a tension downward, T and T. Therefore, the equilibrium of the, and if it's a static one, if you fixed it also, this will become 2T because the pulley does not move. So pulley does not move. It is experiencing two external forces and one more external force here, and therefore does not move. 2T. Equilibrium. Why does it stay stationary? It is because you have obviously connected it here, but there is a force of equilibrium. Otherwise, these two might bring it down, but because you've connected it here now, it will not move and connected with the string. You may not use a string here, you can use another mechanism, but the force of 2T will still get generated here to keep the equilibrium from not moving. Let's look into one more situation of connected bodies. So you have this mass. This is your pulley and another mass. This is 5 kgs and again 15 kgs. This is angle 30 degrees. Look at the way I resolve it. This is my actual weight in x and y axis, mg. This is the component of the weight in this direction along the incline, and this is the perpendicular to the exactly. तो इसमें हमने क्या करा है, हमारा जो x and y एक्सिस है, ये x एक्सिस है, ये y एक्सिस है, हमने नया ले लिया. This is our new x axis. This is our new x axis and this is our new y axis. We've rotated the axis. It was earlier looking like this. We have moved x axis by a certain amount. It has undergone what is called as a translation. So it has, and then of course this has also become a perpendicular. This has also rotated by the same amount. So our new axis is looking like this. This is our y axis, which is rotated by theta. This is also rotated by theta. In this situation also, if you notice this, the tension in the string is appearing here and pulling away the block. The tension is appearing here. The weight obviously is bringing it down, right? 10 into G. But tension is appearing here also, pulling it upwards. So if I were to write a free body, and it's a single string, so same tension. In a single string, same tension. This resolution, etc., we will do. I'm just showing you tension making an appearance. And look at this block, free body diagram of this block. The tension is on this side. If this is this, and if this wins, mg sine theta is trying to bring the block towards left, and the tension is trying to take it up. So you will subtract it. If you assume finally the blocks goes on the left. So the left force is bigger than the tension, m into a. If you have to write for this, you can also do that. Tension will pull it up because it is going towards the left. It will start going up. Tension will win the war here. Minus whatever is the mass of this block into a is equal to, into the mass into m2 a. So this acceleration and this acceleration is same because they're connected bodies. They're moving together with the same acceleration. They're connected by a common string. A common string also implies the common tension. We don't need to worry about how we did this resolution and all that. Not at this stage. We're just into second class of Newton's law. But we have covered a lot of distance, knowing fully well that you have limited time right now. We're trying to cover as much as we can. Any doubts in your mind that come that you're not able to understand something? We can take any number of examples and the behavior of
inclination वाला मुझे नहीं समझ आ रहा.
उसका inclination छोड़ दो, forget the inclination part. Tension समझ में आया? How the tension makes an appearance in the string, that is more important.
Yes.
Okay, good. So let me just give you one more question and I should see it very carefully how it makes an appearance. Okay, so that is more important. Forget that part that. Wait. So I will draw a situation. You can solve it with multiple ways, but this is one situation where it is more about tension than any other thing. Okay, so very similar to what we did. This is your mass. It has its own weight, so one force on it. It is connected to one string here and another string here. So M2G, this is alpha and this is beta. So there is a tension here, pulling it, T2. Separate strings, separate tensions. The block is stationary. It's in equilibrium. Okay? We have to find what are the values of T2 and T1 for this block to be in equilibrium. Equilibrium means neither it is moving in x-axis with the acceleration the resultant forces on x is 0 vectorially, and the resultant of all the forces on y axis is also
सर
0.
mg के साथ क्या एंगल बना रहा है वो?
Correct. कौन?
m. So can we use Lami's theorem?
Can. You can. But अभी नहीं लगा रहे हैं हम उसको. You can. Allowed है. You can easily apply it, right? You know Lami's theorem. 3 forces, and therefore you know how to write the sign and all that. And you know the value of mg. For example, mg is given to be 100 newtons. And you know the values of alpha, beta, gamma. So cake walk, right? एक second में आ जाएगा आंसर T2 और T1 का. Provided you know alpha, beta, something, right? One of them. And the total angle is 360 degrees. So you know this angle anyway, which is one of the angles. And then you know this angle. One, then you can find the other one also. But right now we are trying to understand how the tension works. The tension is pulling this block like this. So one part of this tension, now tension and vectors. So if I look into the free body diagram of this block, look at the way it works. Tension pulling it away. Tension pulling it away. Okay, थोड़ा सा मैंने angle change कर दिया. Don't worry about it. Or I can draw the same tension here. This is mg. So this is tension. This is alpha. So this will be 90 minus alpha. Okay, 90 minus alpha. If this is beta, then tension 2 is 90 minus beta, because I'm always worried about the angle with the horizontal. Okay, so this is my T2 and this is my T1. So this is T2 base, right? I'm looking at the base, x-axis forces. T2 cos of 90 minus alpha, and this is T1 cos of 90 minus beta. Since there is a equilibrium in x-axis, therefore T2 cos of 90 minus alpha in magnitude will be equal to T1 cos of 90 minus beta, which means it is T2 sin alpha is equal to T1 sin beta. This is equation number 1. We are given alpha, beta in the question, etc., etc. is different thing. Similarly, so x-axis equilibrium taken care of. Horizontal components of the respective tension making different angles, balancing each other. Let's look into the other situation of y-axis. Weight also needs balancing. If I draw that, right, and I use the same concept which I used, actually my angle was this, right, with the vertical alpha. You'll have to remove your cursor. Yeah. So this is beta. This is T2. This is T1. So this will become horizontal now. So this will be T2 cos alpha, pulling it, because it is pulling, right? So I have to complete my triangle correctly. Pulling horizontal, I've already cancelled on both the sides. Cancelled. Pulling up is what I'm worried about. So T2 cos alpha plus T1 cos beta. So T1 cos beta plus T2 cos alpha is equal to the weight. The y-axis equilibrium also taken care of.
सर अगर वैल्यूज निकाले तो हम लैमिस थ्योरम का तो निकाल सकते हैं.
You don't discuss Lami's theorem right now. Let's focus on learning tension. When we become proficient in multiple techniques, we will decide which technique is better than this. Short answer, if we know the values, yes. But with that, you will not come to know what is tension behavior. This was not given in the question, that the tension is acting like this. What was given to you in the question was only this diagram. That's all. Nothing. What is the condition of equilibrium? You had to decide this tension is acting like this, pulling the, and then of course rest is vectors. Make sense?
Yes.
Lami's theorem is fine because we know Lami's theorem. But what if we don't know Lami's theorem and we're in the process of learning tension? Okay? So what I will recommend you now is just go and see some of the stuff. I'll send you some notes on tension and some links and all that. Have a look at it briefly for 15, 20, 30 minutes, and that's about it. Then we will continue to have this discussion. But I have given you a lot of perspective today on quick basis on the concept of contact force, Newton's third law, and connected bodies with a string, how the tension works. All of them are very, very important. Of course, we will learn few more things before we start solving big numericals, but this is easier one. These are the building blocks of those big numericals. Make sense?
Yes, sir.
All right, so we will now close this class and you will have to go back and find out about your projectile assignment. Where exactly is it? And some of the questions are very good. Please complete